Before we actually run an absorber dyno test, there's a concept I'd like to explain, and it has to do with finding when you run a test, you'll start recording and then you'll stop recording. In between the start and the stop, you may have the engine running at part throttle, at idle. You might blip the throttle and actually rev it up to 6,000 RPM a couple of times. And then you're going to actually make your test. When you're making your test, you are at full power. The throttle is wide open. We call it WOT, W-O-T, or wide open throttle. It's very important for the program to be able to figure out where is the engine at full power or wide open throttle and where is it not. For example, in this test, if we graph this test versus time, and we graph the engine RPM and the torque, you can see here that the blue line is engine RPM, which is also dyno RPM, and you can see here it starts at a low RPM. You probably started up the engine or something, and then it came to life, blipped the throttle a little bit, started loading up the dyno, it came down, starting to release load on the dyno, it's starting to accelerate, and then at the end, he killed the engine, closed the throttle, and it came down. And you can see torque is very low here. It kind of goes up and down a little bit. Then it's fairly stable through here, through this normal looking axle. And then at the end, again, it falls off. Now you can see here, what the program will do is, let's say at 4,000 RPM, every place the program sees data at 4,000 RPM, it's going to take a snapshot of the torque and say, and average it in with all the other torque. So here we are at 4,000 RPM, blue, and you can see down here, we got a fairly low torque number. We go back through 4,000 again here, and the torque number is quite a bit higher than it was here. And then on this real axle, probably where we're now close to full throttle, we go through 4,000 RPM here, and the torque is much higher. And then as we decelerate over here, we go through 4,000 again, and we're down to 160 foot-pounds. So you can see if we average in all the 4,000 foot or 4,000 RPM data, we're going to have a low number, we're going to have a good number for torque, and then over here we're going to have kind of a low number for torque and then another real low number for torque. So the number we get at 4,000 RPM, if we use all this data, is pretty low. This is the good 4,000 RPM data point for torque right there. So somehow we've got to figure out which of these 4,000 RPM data points is good and which ones aren't. And it's a pretty important concept, and the program is actually pretty smart at doing that. So let's go make a graph of this. And instead of doing that, let's just make a standard torque and horsepower graph. And you can see that's why this torque and horsepower graph looks kind of funny. Why we got all this funny stuff down here, and then it comes up, and up here it looks fairly normal. But from here on down, it looks kind of funny. So how can we have the program figure out what's good data and what isn't good data? There's actually 4 different ways of the program figuring out what is good data and what isn't. First off, the program can itself automatically find the start and end of the test. But you have to tell it whether you do an accelerating test or a decelerating test. Another method, which wouldn't work good in this situation, is all the recorded data is the test. And you can see, like I said, in this situation, because we got some of that blipping the throttle at the beginning stuff, all the recorded data is not good data. But you have an option. You can edit the test and just keep the good stuff. Or a fourth option is you can actually have a handheld or some kind of wide open throttle switch that marks the test. And for all the time that the switch is held down, the program says this is good wide open throttle data. So if you had a switch on your throttle and that switch was activated when you went wide open throttle, that's another way of marking the test. Now the way you tell the program what you're doing is here in test conditions, down here. your absorber dyno specs. This was not available in the inertia dyno stuff. Okay, so we could start high RPM, pull down to low RPM. That's a decelerating test. You could start at a low RPM, release to a high RPM. That's an accelerating test. A lot of people feel that the decelerating test is actually easier to control. Or you can use all the recorded data as the test. And you also have, you can see if we choose that, you don't have those RPM settings. If you're doing the accelerating or decelerating, you can put some RPM limits in here that says below 3,500, I'm not even interested in. Okay? If the program never sees 3,500, if you start your recording at 4,500, well, then that's the lowest RPM. If you start the RPM recording at 2,500, it will not show you a power run below 3,500. You'll still have the recorded data at 2,500, but it will not show you anything in the power run below 3,500. And the same at the top end. You go up to 8,500, it's going to stop it at 75. You only go up to 6,200, it'll go up to 6,200. So let's do this. Let's tell the program we are going to start at a low RPM, release to a high RPM, and we're going to tell it, we're going to measure torque and horsepower from dyno. And as soon as I make those changes and back out of this screen, it says, do you want to make that significant change? I'm going to say yes. And the program has now gone through and found, wow, look at how nice that looks. It's cleaned up the power curve. The reason it's cleaned it up is because now the program, let's here we got a nice power torque and horsepower curve, but let's graph this data versus time like we were doing before. Okay, what do we got? Oh, I got to get rid of those other torque channels here. Get rid of this stuff down at the bottom. Okay, this is what we had before. We are graphing all the data. Now what I'm going to do is I'm going to click on graph type. I'm going to say graph just the power run. And you can see it's gotten rid of a lot of the data. And you don't have that blipping the throttle at the beginning or the fall off that you hit up here at the top end. It is now saying this is what I'm basing, this data here, just the power run is what I'm basing the torque and horsepower curve on. And you can see the torque number makes a lot more sense. You got all this high torque in here. You don't have any of those real low torque numbers. So I'm now going to show you a comparison of what went on here. I'm going to turn this back on to all the recorded data is the test. And you see it's got 27 seconds. Now we got this bad data. And I'm going to make a graph of this again. There's the entire test. Even if I say just the power run, we're still getting the entire test. And I'm going to add a test here. A test that I believe, let's say this one here, where we've done this stuff correctly, where we've correctly had it identify the beginning and end of the test by telling it was an accelerating test. And you can see here, I'm going to do this. This is for time aligning. I'm going to move this the graphs one over the other. And this is giving you a nice little overview here of the time alignment and how it works. And see this test that is highlighted in pink now, that is a test that is going to be moved. And as I click on the button, you can see here the amount of time it is moving. And I'm moving the wrong one. I've got to move. But if you hold the shift key down, things will happen faster. You can see there, that shows you it is the same exact data. It's just that one test uses all the data and one test uses just the good data. So I'm going to turn off time alignment by doing that. Let's see. I'm going to turn off the time alignment by clicking on Format. I'm sorry, it's View, and then Show the original timing. And now you're back to that graph. And if I do compare these two graphs on a torque and horsepower curve, you can see where we've correctly edited out, or not edited out, let the program find the beginning and end of the run, just the wide open throttle data. You see how much better this power curve looks than this low value here where it averaged in all that low torque stuff and then it went way down here to a very low RPM. So you can see how important it is to get just the wide open throttle data being marked off as the good data. Now there is another way of working with this, and you saw in that list of 4 options. If we use all the recorded data as the test, you can actually cut out the bad data manually. And here we show engine RPM. And what I'm going to do, and I'm going to show you something else first though. Before we do this, it's always, you want to cancel? Yeah. When you do this, you always want to save a copy of this test just in case something gets screwed up, because this change is permanent. I'm going to call it cut, put a cut in there so it knows that we cut something out, because the change you make here is permanent. And you may want to, if you don't keep a copy of it and you do something wrong, you'll be kicking yourself. So we've made a copy of it. And what I'm going to do here is you draw a box by positioning the mouse where you want to start, drawing a box around what you call the good data. And what I've done here is now I've eliminated this data, and I've eliminated all of this stuff here. And what I've got is now what I believe is just a good wide open throttle data. It's not showing you torque. We can only show you an RPM on here when you cut this. But I'm going to say, okay, keep this section. And it says, do you want to keep this? Yep. It shows you that. And again, even though we're using all the test data for the run, like shown here, because we've cut out the bad stuff manually, we now have that good power curve. So here we have 3 tests overlaid over each other. These 2 that all agree almost exactly, the purple and the blue, are from when we manually cut the data, or when we let the program find the start and the end based on you telling it was an accelerating test. And here, the erroneous stuff where we said use all the recorded data as the power curve. So you can see how important it is. If you do things right, things work out very well. Do things wrong, and you're like this light blue line, you have some pretty erroneous data.